Hello everyone, very good evening. Kindly confirm if audio video is clear. Very good evening, Ashwini. Please confirm if audio video is clear. Okay, so this will be the seventh lecture of the database management series YouTube course and the third lecture on structured query language. Okay. So in the last class, what did we discuss? In the last class, we tried to understand the concept of subquery. There are two different types of subquery. One is independent subquery. When do we say that inner query is an independent query? If the inner query can be executed independently, if it does not require any attribute specified in the outer relation, then we say that it is an independent query. If the inner query requires the attribute specified in the relation of outer query, then we say that query is a correlated query. Okay, so if the query is an independent query, then we will first execute the inner query, and then based on the output of that inner query, we will execute the outer query. But if the query or if the subquery is a correlated subquery, if the subquery is correlated subquery, then we will have to execute the inner query with respect to each tuple of outer relation. Clear? So, what happened? Uh, Today we will see the examples of correlated subquery, and then we'll see two more clauses of SQL. One is as a clause, another is with a clause. With is also used with as clause, so don't worry. With as are the same thing. Then we'll see examples of as and with clause. Okay, so what happened in the last class? So this is your correlated subquery. What happens? So the inner query, this is your inner query, uses the attribute specified in the relation of outer query. So what is the order of execution? We said that we'll take the first tuple from outer relation, and with respect to first tuple of outer relation, we'll execute the complete inner query. Based on that, we'll be able to decide whether the where condition is true or false. Based on the output of where condition, we'll decide whether the first tuple should be selected or not. Clear? So there are various operators which are used with these queries. We have already discussed this operators in any and all and exists in the last class. So this is just for the purpose of revision so that you understand that what all will be required for the today's session. So yesterday I gave you a homework problem. So let's start with the homework problem. So this is your homework problem. This is your correlated subquery because the inner query uses the attribute PID of the relation C, PID of the relation C, and this relation C is defined in the outer query, right? So, how exactly the query will proceed? Come on. So, let's say that the catalog relation is as we have catalog relation. It has three attributes: SID, PID, and cause. S1 has supplied part P1, S1 has supplied part P2, S2 has also supplied part P2, and S3 has supplied part P3. That's the situation. 20, 30, 25, 15. So this is our catalog relation that we have renamed as a C by this operation. Then we have parts table. That we have renamed as P, and it has only two attributes, I believe. Yes, PID and color. Then I ask that what output will be produced if this query is executed on these two instances of catalog table and parts table. So how do we proceed? So what did I say? That we will take the first tuple. So let me start with the first tuple. Let me start with the first tuple from the catalog relation. So you need to be very careful when you execute a correlated query. So what will happen? Let's try to understand. So we'll first go with the first tuple. So we'll select the first tuple. With this first tuple, we'll first go to the first tuple of the part table. So what did I say? For first tuple of catalog table, we first need to execute the inner query on the complete inner relation, that is complete part relation, right? Now what will happen? We need to check whether, so we'll take the first tuple of the part table. We'll take the first tuple of the part table, then we'll check for the where condition. So P dot PID is P1, C dot PID is P1, so this condition is true, and P dot color is equals to red, so condition is true. So this will get selected. So the first tuple of the part table will get selected. Now what will happen? With the same first tuple of the catalog table, we will go to the second tuple of the part table. Now what will happen? So from part we have taken the second tuple. The PID in the catalog table is not same as PID of this particular tuple of the part table. Therefore, condition is false. If condition is false, then this particular tuple will not get selected. Third is you will go with the first tuple of catalog table to the third tuple of part table. Again, this particular tuple will not get selected. Now, with respect to first tuple of the catalog table, we have executed the complete inner query and we get the idea that the output of the inner query will contain one tuple P1 red. Will contain one tuple P1 red. So, inner query result is not empty. Inner query result is not empty with respect to first tuple of the catalog table. Therefore, exist will return true. Exist will return true. And because exist return true, therefore, first tuple of the catalog table will be selected. First tuple of the catalog table will be selected. So, after executing so many things, only you will be able to say whether the first tuple should be selected or not. So, where condition is true for the first tuple, therefore corresponding SID will be selected. Ultimately, not the complete tuple, we only need to select the SID. Therefore, SID from the first tuple will be selected. Now what, sir? Then we'll take the second tuple of the catalog table and we'll go to the first tuple of the part table. PID in the catalog table is P2, PID in the part table is P1. Therefore, condition is where condition is false. Therefore, tuple will not be selected. Then we will go to the second tuple of the part table. PIDs are equal, but condition color is not equals to red. Therefore, condition where condition is again false. Then with the second tuple of catalog table, we'll go to the third tuple of part table. PID is P2 here, PID is P3. Therefore, first condition is false. So none of the tuple of the part table is selected with respect to second tuple of catalog. Therefore, inner query result is empty with respect to second tuple and exist will return false. When inner query result is empty, then exist will return false and this particular tuple of catalog table will not be selected. Therefore, the SID of the second tuple of the catalog table will not be present in the output. Then we'll take the third tuple. Let's go with the third tuple. take the third tuple of the part table and go to the third tuple of the catalog table and go to the first tuple of the part table. P2 is not equals to P1, therefore it will not get selected. P2 equals to P2, but color is not equals to red, therefore it will not get selected. P2 is not equals to P3, therefore third tuple is also not selected. So for the third tuple of the catalog table, also the inner query result is empty, therefore exists will return false and third tuple will not get selected. Third tuple will not get selected. What is the definition of tuple? Tuple is a collection of different fields. Different fields is nothing but the attribute. Relational model. Each record of the table is called a tuple. Tuple is a collection of different attribute values. So here the different attribute values are values of SID, values of PID and values of cost. So this three together will form one tuple. This is one tuple, this is another tuple, this is another tuple, this is another tuple. Each record is a tuple, Ashwini. Okay, so let's go with the go and check that what happens with respect to fourth tuple of the catalog table. Let's check with respect to fourth tuple. Now you will take the fourth tuple and you will go to the first tuple of the part. PID is P3, PID is P1, therefore it will not get selected. PID is P3 in the catalog table and PID is P2 with respect to tuple of part table. Therefore again condition is false. Here PID in the catalog table is also P3 and PID of the part table is also P3, as well as color of that particular tuple of the part table is also red. Therefore where condition is true with respect to third tuple of part table corresponding to fourth tuple of catalog table. Therefore with respect to fourth tuple of catalog table, inner query result will not be empty, and because if it is not empty, therefore exist will return true. Exist will return true, and the third tuple will be where condition is true for the third tuple. Oh, sorry, fourth tuple, where condition is true for the fourth tuple. Therefore, SID of the fourth tuple will also be selected. So only two SIDs are selected. First one is S1, another one is S3. So basically, if the supplier with SID S3 has supplied a part whose color is equals to red, then that particular SID will be selected. S1 has supplied a part P1 and the color of P1 is red, therefore this one is also selected. S1 has supplied part P2 and P2 is not of red color, therefore this is not selected. S2 also has supplied a part P2 and P2 is not of red color, therefore this tuple is also not selected. So only the SIDs from the catalog table will be selected which are corresponding to a red color part. Clear? So what will be the output, sir? The final output, if we look at this, sir, the output of this particular query will contain two SIDs. One will be S1, another will be S3. Got the idea? So what exactly is produced by this query? This query will return the SIDs of all the suppliers who have supplied some red color parts. This particular query will retrieve the SIDs of the suppliers who have supplied some red color parts. Clear? Okay, so that's one example. This is the second homework question that I gave you in the last class. Come on, let's look at this. Consider the relational database with the following four schemes and their respective instances. So we have four tables. One is student, another is department, another is course, one is register. Four tables with the corresponding instances. Now, what is available? Student table will have student number, name of the student and the department number of that student, department number and department name in the department table. The course will have course number, course name and the department number corresponding to that particular course, and register table will have that which particular student has enrolled for which particular course, has registered for which particular course. Clear? So these are the tables which are available. Now let us look at the query that is given in the question. This is your SQL query. Select asterisk from student as S where not exist something. Select C number from course where department number is equals to D01, except select C number from register where student number in the register table. So this, come on, sir, when you say s dot student number, when you say s dot student number, then this is the attribute value from the outer relation, and this s number is actually an attribute of the register table. The first s number is the attribute of register table, and the second s dot s number is an attribute value from the outer relation student, which is aliased as s, right? Okay, so you understand one thing, that sir, this particular query requires an attribute value defined in the outer relation. Therefore, this is a correlated subquery. What type of query is this? Correlated subquery. But the first query, that is select C number, that is course number from course where department number equals to D01. This is an independent query. No matter what other information are available, this query can be executed independently. This query can be executed independently. Therefore, it is independent subquery. Right? Now what will happen, sir? Independent subquery will be executed first. So we will select the course number from the course table where department number is D01. So look at the course table. From the course table, first of all, select the tuples in which department number is D01. Therefore, these two tuples will be selected because here department number is D01. Here also department number is D01. So course number from those corresponding tuples will be produced as output. So this independent inner query will produce the output as a C11 and a C12. C11 and C12 is the output of this independent subquery. Okay, so this information is available. Now this second part of the subquery is actually a correlated subquery. Therefore, this second part will be executed with respect to each tuple of the outer relation. Will be executed with respect to each tuple of the outer relation. So first of all, you will take the first tuple from the student table S. So first of all, you will take this first tuple from the student relation. Then with this tuple, you will go to the first tuple of the register table. SID, the student number in the register table is exactly same as student number in the student table. Therefore, corresponding course number will be selected. Clear? Now, with this first tuple, we'll go to the second tuple of the register table. Again, student number in the register table is the same as student number in the student table. Therefore, this course number C12 will also be selected. Now, for every other tuple of the register table, the student number in the register table is not same as student number in the tuple of student table. Therefore, for none of these tuples, the where condition will be true. Right? So with respect to first tuple, the correlated subquery will produce the output C11, C12. Will produce the output with respect to SID S01. So these are the courses which are produced. These are the list of courses which are produced with respect to student S01 of the student table. Now, what will happen? Sir, when we subtract C11, C12 from C11, C12, the result will be 5. So when you perform subtract this from this, the result will be 5. Because the result is 5, therefore inner query result is empty. When inner query result is empty, exists will return false and not exists will return true. Not exists will return true. So let me explain that we will have student tuple S01, S02, S03, S04, S05. So S01, S02, S03, S04, S05. So with respect to S01, this is the complete inner query. Inner query result is empty, so not exists will return true. Because not exists is true, therefore the tuple with respect to S01, that is S01 James D01, will be selected. S01 James D01 will be selected. So the second tuple of the student table is S02 Rocky D01. Now let's try to understand that what will happen with respect to second tuple. So if I subtract with respect to student 0, this will be 5. Okay. Now let's check that what will be produced with respect to second tuple of the student table. So what values will be produced with respect to second tuple of the student table? So you all know that SID should be same. So if you are going with the SID as student number S02, then only the tuples with respect to S02 will be selected and no other tuple of the register table. No other tuple of the register table will be selected. Therefore, the only course that will get selected from the register table with respect to student S02 will be C11. Will be C11. So, with respect to student 02, the output of this second query will contain C11. Now, out of C11, C12, if you subtract C11, you will be left with C12. Out of C11, C12, if you subtract C11, then you will be left with C12. That means for second tuple of the student table, inner query result is not empty. Therefore, exists will return true, whereas not exists will return false. That means for the second condition, for the second tuple of the student table, where condition is false, therefore this will not get selected. Okay. Now, the third tuple is Jackson D02. Let's check that what exactly will be produced with respect to student number S03. What exactly will be produced with respect to student number S03. So forget about S02. So the only tuples which will get selected with respect to student number S03 will be the tuples from the register table in which the student number is S03. So this. So you will have the values C21, C22 and C23. So the courses which are registered by student number S03 are C21, C22, C23. C21, C22, C23. Sir, how do we perform subtraction? The tuples which are present in the first relation but not present in the second relation. So here, both the tuples are present in the first relation as well as in the second, therefore result is 5. C12 is the tuple which is present in the first first table but not present in the second table, therefore C12 is the output. Here, C11 and C12 both are present in the first table but not present in the second table, therefore both will be present in the output. Right? Again, the only thing that you need to see is that inner query result is not empty with respect to third tuple. Therefore, exists will return true, but not exists will return false. If where condition is false, therefore, the particular tuple will not be selected. So, fourth one is James D01. D01. Now, let's look with respect to student 04 that what exactly will be present in the output with respect to student S04. So, when we take student S04, the only tuples which will be selected from the register table will be the one which are with respect to the student number S04. So, this will get selected, this will get selected. The output will be C11, C12. The output with respect to student S04 will again be C11, C12. Right? So out of C11, C12, if you subtract C11, C12, result will be 5. Again, with respect to fourth tuple, inner query result is empty, therefore exists will return false, but not exists will return True. Therefore, the fourth tuple of the student table will be selected. Fourth tuple of the student table will be selected. For example, Millie D02. Let's check what will be produced with respect to S05. What will be produced with respect to student number S05. So, the condition is that student number in the register table must be same as the student number in the student table. So, the student number is S05. Then the only tuples which are with respect to a student S05 will be selected. Therefore, the output of correlated subquery, with respect to fifth tuple of student table will be C11 and C21. Yes, will be C11 and C21. So, out of C11, C12, C11 will get subtracted, but you will be left with C12. Again, with fifth tuple of the student table, inner query result is C12, that is not empty. Therefore, exists will return true, but not exists will return false. Therefore, this tuple will also not get selected. So, the question is the number of rows returned by the above SQL query. Sir, two rows are returned. Two rows are returned by above SQL query. How many rows are returned by the above SQL query? Only two rows. One will be with respect to a student S01, another will be with respect to student S04. Clear? Except is nothing but minus. Okay, so these are the questions that I gave you as homework in the last class. Now, we will understand about some more things and we will see the questions related to as a clause and with a clause. So, these are again two clauses that you need to understand. So, why do we use as clause? Sir, as a clause can be used to rename a column name, that is attribute, or it can be used to rename the table. This is more explicit way of renaming something. This is more explicit way of renaming something. So, if you simply, let's look at this. Sir, if you say student as S, then you are renaming student as S. At the place of this, if you simply write student space S, then also a student will be renamed as S. Both will do the exact same thing. Both will do the exact same thing. An alias will be created with name S corresponding to table student. Here also an alias with name S will be created corresponding to relation student. So this S is a more explicit way of renaming something. It can be used to rename almost everything. It can be used to rename almost everything, right? So generally we say that it is used to rename column, that is attribute, or the table name, but it can be used to rename almost everything. That is, if some output is produced by a subquery, then that particular output can be given a new name. That particular output can be given a new name. So we'll see that how exactly as clause works with the help of an example. So as clause is used to rename a column or table with an alias. So or it can with an alias. And what will be the scope? What will be the scope of that alias? It will be valid only only during the execution of query. The moment the execution of query completes, the alias will no longer exist. Only when you are executing the query, that particular alias will remain valid, right? So, an alias only exists for the duration of the query. That means whatever name. So, if you are saying student as S, then this alias S will exist only during the duration of this particular query. Once the query executes completely, there will be no alias with name S. Clear? So, these are just the temporary names. These are temporary names. These are not permanent. Okay. So let's look at the example that, sir, what exactly can be done? This is again a gate question. We'll try to understand the concept of as clause using this. Sir, generally, if you simply want to rename an attribute, or if you simply want to rename a relation, that will be easy. But this is an explicit question. What did I say? That as can be used to rename almost everything, right? So let's look at this query. Let's try to understand this particular query, and you will see that what all can be done using as a clause. So consider a database that has the relation schema employee with attributes employee ID, employee name, and department name. There are three attributes. An instance of the schema employee and a SQL query on it is given. Clear? So this is the instance and this is your SQL query. First you need to understand, sir, the name of the table is employee. So the only table, the only relation that is available in the database is employee. Right? But look at the query. Look at the query. What exactly is happening? What exactly is happening? Sir, select average something from EC. So there is no table with name EC. There is no table with name EC, right? But there is something else. There is something else. So we are saying select average EC dot number from EC where, look at this, where the tuple department name comma number is in. So this tuple will come from the table EC. This has to be a tuple from EC and this tuple must be in the output of this subquery. Come on, sir. This is a subquery. Sir, what type of subquery is this? First of all, we need to identify whether this subquery is a correlated subquery or it is an independent subquery. So the concept is, it is trying to select the department name and count of employee ID. So along with the aggregate function, if you are using any attribute name, then that attribute must be present in the group by clause and it is happening. So there will be no error, it will execute, right? So we need to select the department name and count of employee ID. So when group by clause is present, then this aggregate function will be applied on each group. That means for each department, we will count the number of employees, number of employee ID. For each department name, we will count the number of employee IDs. So this will be select this comma this as, oh, please look at this. For time being, this is just an alias. This is just an alias. What, sir, whatever is selected will be given a new name. Whatever is selected as a output of this subquery, that will be given a new name EC, and the first attribute will become department name and the second attribute will become number. So first of all, forget about this green color region and think about this query that select department name comma count of employee ID from employee table. So it is using the employee table and group by department name. So what will happen? So what is the order of execution? So this is an independent query. This is an independent subquery. It does not use the EC table. It actually creates EC table. The subquery is creating a new alias and the main query will execute based on that alias. The outer query or main query will use that particular alias for its execution. The subquery is creating that alias. Subquery will create a new relation with name EC. New relation with name EC, and the main query will execute on that new relation EC. So what will happen? So first of all, this inner query will execute. So what will happen because of this? So first of all, from employee table, so we'll take the employee table. There is no where condition. That means all the tuples will be selected. From all the selected tuples, you will group those tuples based on department name. So one department with name AA will be created, another department with name AB will be created, another department with name AC will be created, another department with name AD will be created, and another department with name AE will be created. So you have created these groups. There is no having condition. There is no having condition. Therefore, all the groups will be selected. There is no having condition. That means all the groups will be selected. Now, on all this group, this aggregate function will be applied. This aggregate function will be applied. So you will count the number of employee IDs in group with a department name AA. So what output will be produced? Sorry, here you will get department name. Let's look at this. So you will get department name, and then you will have count of employee ID. Count of employee ID. Okay, so department name will be AA. With respect to this department name, the count of employee ID will be 4. So we are done with respect to first group. Second group is of department AB. So the name of the department is AB, and the number of employee ID in the department AB are 3. The third group is of department name AC, and the number of employee IDs in the department AC are also 3. Fourth group is department AD. So AD, and the number of employee IDs in the department AD are 2. Then we have AE as the last department name, and the number of employee IDs in the department AE are 1. So this will be the output of this subquery. But what is happening? So the output of this subquery will be given a new name EC. That means from now on, this output will be treated as a new relation. This output will be treated as a new relation whose name is EC, and the first attribute department name will still have the same identity, that is department name, and the second attribute, that is the value corresponding to count employee ID, will become number. The values with respect to count employee ID will be given a new name, or will be given a new alias, that will be number. So after the execution of this subquery, you will have a new relation or an alias which will be valid only during the execution of this query. You will have a new alias in which the name of the relation will be EC, and that relation will have two attributes. First one will be department name, another will be number. Now, once you have executed the subquery, you will go and you will execute the main query. Now what will happen? Sir, how exactly main query will execute? So it will take the first tuple from the EC table. So it will take the first tuple, that is AA, 4. It will take the first tuple from the relation, and here the value is AA, and the number with respect to first tuple is 4. Now it will check whether AA, 4 is in this set of tuples or not. So here there is one tuple, there is another tuple, there is another tuple, there is another tuple, there is another tuple. So this time the comparison will be tuple wise. So these are the set of this is a set of tuples produced by inner query. Now the thing is that, sir, your outer relation is taking a tuple from the EC table and it is checking whether the tuple is present in the EC table or not. Your main query is taking a tuple from the EC table and it is checking whether the tuple is in the EC table or not. Come on, sir. For every tuple of EC table, it will be present in the EC table. For every tuple of EC table, that tuple will be present in the EC table. That means for every tuple of EC table, this where condition will be true. For every tuple of EC table, this where condition will be true. So what will happen? Sir, here you will have AA4, AB3, AC3, AD2, AE1. So this first is belongs to this, therefore it will get selected. Second one belongs to this, therefore it will also get selected. Third one, AC3 belongs to this, therefore it will also get selected. AD2 belongs to this, it will also get selected. AE1 belongs to this, therefore this will also get selected. So the output of the main query will select all these tuples. The output of main query will select all these tuples, in which the first attribute will be department name and the second attribute will be number. Now finally, on all these selected tuples, this aggregate function will be performed. On the selected tuples, this aggregate function will be performed. That is, it will average the number. It will average the number value of the output. So it will eventually average out this all values. So the average of number will be nothing but it will be 4 plus 3 plus 3 plus 2 plus 1 by 5. So what will it be? 6, 10, 13 by 5. So it will be 2.6. It will be 2.6. So the output of the query will be 2.6. The output of this query will be 2.6. Got the idea? So what is important? So the queries are always easy. SQL query will be damn easy. The only thing that you need to understand is that in what order the query will execute. In what order the query will execute. So in general, clause as will be used to rename an existing table, or it will be used to rename an existing attribute, but as can be used to rename almost everything. So in this specific situation, the output of a query is being renamed by a new relation whose name is EC, and the attribute of the output are also being renamed as department name and number. Getting the idea? So the output of this subquery is being given a new name EC, and the attributes are also being renamed. The name of the first attribute remain as it is, that is department name, but the output of the subquery will have the second attribute as a count employee ID, but that second attribute is being renamed as a number. So what exactly is being produced by this inner subquery? So inner subquery gives me the name of the department along with the number of employees in that department. This gives me the name of the inner subquery gives me the name of department along with number of employees in that department. Got the idea? And the outer queries just average out the total number of employees in each department. Clear? So that's the as a clause. So the next one is similar in nature but works in a different way. So with clause is also used to provide a subquery a new name. So here also the output of a subquery is being renamed using the S operator. With clause is also used to provide a name to the output of a subquery, but it works little differently. So here the output will be produced first and then it will be renamed as a new table, but how exactly with clause will work, that's what we need to understand. Okay, that's the same thing. So the answer for this particular query will be 2.6. Answer will be 2.6. So let's look at the with clause. So why do we use with clause? So generally with clause is used to make the query more understandable. If you use the with clause, it will be easy to trace the query that what exactly is being done by this particular query. So why do we use with clause? The reason with clause is used to make the query more understandable. So it will give you a clear notion that how exactly the things are being done. So what exactly will be done by with clause? Sir, again there will be a subquery and the output of that subquery will be given a new name by with clause. So the with clause is mainly used to provide a subquery block a name, or basically a new name. The with clause is mainly used to provide the subquery block a new name, and that new name can be referenced within the main SQL query. So this is just a subquery. The output of that subquery will be given a new name using with clause, will be given a new name using with the clause, and that new name can be referred by your main SQL query. So what's the difference? What is the difference between with to rename the subquery output by a new name, or as clause in order to rename a subquery output by a new name? So the only difference is that if you use as clause to rename, if you use as a clause to rename or to provide a new name to the output of a subquery, then the subquery will be written after the main query. So first you will have your main query, and this is your subquery. This subquery will be independent subquery. This will be, who's this? Bhavesh. Bhaveshji, I have never seen your name in the class, right? Did you attend the classes while they were live? Wrong place, wrong question. Yeah, wrong place, wrong question. Right? I'm in the middle of something else and you are in a different world. Okay, so let me explain once again. Sir, if you are using as a clause to provide a new name to the output of a subquery, then in that specific case, the subquery will be eventually, then that particular query will be a subquery with respect to main query, and main query will use the name defined by as a clause to the output of the subquery. But if you use with a clause, then things will be different. If you use with a clause, then things will be different. With a clause, first you will execute all the subquery. First you will execute all the subquery. So this will be subquery block 1. This will be subquery block 2. There may be any number of subqueries. And then after all those subqueries, you will write your main query. So here what is happening? So this is your main query, and within this main query you have a subquery. Come on, let's look at this. So within this main query you have a subquery. So because this subquery is an independent query, this independent subquery will execute first and it will create a new name EC, a new relation EC. Then your outer query, that is main query, will execute. But in case of with clause, first of all you will provide new names to all the subqueries, output of all the subqueries, and then you will use those names in the main query. So main query will be written after you have defined all the subqueries with clause. Main query will be written after all the subqueries with clause. Here, first you will write main query, and within that you will write your subquery that will use as clause. But if you are using with clause, then first you will define all the subqueries with clause, and then you will use main query. No, they are not difficult. They are not difficult. You did not follow all the lectures properly, therefore they seem difficult to you. If I ask you that What exactly is difficult in this question? Please tell me. What both? This one is difficult? This one is difficult? See, there is only one order to execute SQL query. If you understand that order, every question is easy. There are only 5, 6 different ways of representing an SQL query. There are not more than 6, 7 different ways, right? So if you understand that in a specific situation how exactly things will execute, then no matter how many questions are asked based on the same pattern, you will be able to solve that particular question. I have given one example in which as clause can be used to provide as is present in subquery. I thought it's correlated. As is used to rename. As is used to provide a name to this output. As will be used for what purpose? Sir, as will be used for the purpose of renaming. As will be used for the purpose of renaming. So whatever output is produced by this select clause will be renamed by this as clause. That's what I'm trying to suggest. That as is used to provide a new name to something. That something can be anything. That may be an existing relation, that may be an existing attribute, or that may be the output of a subquery. That may be the output of a subquery. So the output of subquery can also be renamed using as clause, or the output of a subquery may also be renamed using with clause. So that's what I'm trying to differentiate as of now. That if you use as clause to define if you use as clause to provide a new name to the output of a subquery, then your main query will appear before your subquery. But if you use with clause to provide a new name to the output of a subquery, then those subqueries will appear first once you have renamed or once you have executed all those subqueries and you have created those new relations, then only your main query will refer those new tables created using with clause. So let me give you an example. Don't make it complicated, otherwise many of you will flaunt. So with clause is mainly used to provide a subquery block a new name that can be referred by the within the main query. That can be referred within the main query. So how exactly things will work? Sir, what did I say? That before you write your main query, this is your main query. This is your main query. So before you write your main query, you will have some subquery. So let's see that you will use a name with, you will use this clause with clause to create a new relation. Now, how does it work, sir? With, then what will happen here? So here you will define the new name along with attribute information. Define new name of relation along with attribute information. Then you will have as a clause. So this is with as will behave differently. With as is a different from as. With as is a different from as. Now what will happen? So with this new relation and attribute information as the output of this subquery. So here you will have a subquery. What will happen? Sir, with new name defined to the output of this subquery. So what will happen? You can actually see. This. So you have new name, which you have defined, new attribute 1, new attribute 1, new attribute 2, and so on. Whatever attributes are present in the output of subquery, whatever number of attributes are present in the, so this is new attribute. New attribute input. So you will have a subquery. The subquery will execute first. The output of that subquery will be renamed by this new name. Will be renamed by this new name. If that subquery has 3 different attributes, then you will specify the name of the first attribute, the new name for the first attribute, the new name for the second attribute, and new name for the third attribute. So first, this subquery with clause will be available, and after that you will have your main query. After that you will have your main query. Within this main query, whenever you want the output of this subquery, within this main query, whenever you want the output of this subquery, you can call that by this new table, new name. Got the idea? So within the main query, whenever we need the output of subquery, we can refer relation new name, new attribute 1, new attribute 2, etc. Whenever you need the output of this subquery, you can actually, and rather than specifying that subquery, you can use this new name provided to the output of that subquery. Come on. Okay, so let's make it easy with the help of this example. So this is again a gate question. Please look at this. Sir, this is one subquery with clause. This is another subquery with clause. And this is your main query. So do you realize the difference? Whenever we are using with as clause, whenever we are using with as clause, some people call it as with as, some people call it as with, both are correct. So whenever you are using with as, then all the subqueries with clause will be written before the main query, right? But if you are only using as a clause for renaming purpose, then first you will write main query and then you will write your subquery. Got the idea? Got the idea? That's the basic difference. So here, so how exactly this query will execute? So please try to understand. That's this is select distinct name from something grouped by water scheme. This is your subquery 1. This is your subquery 1. This is your subquery 2. Right? So look at this. So consider the following database table named water scheme. So you have a table whose name is water scheme, which has 3 attributes. One is scheme number, Another is the district name in which the scheme is being uh, implemented, and the capacity, right? So it says that the scheme number is 1, district name is Ajmer, and capacity is 20. Scheme number is 1, district name is Bikaner, and capacity is 10, etc. Now look at this query. Select a district name. So you want to select district names, comma, sum of capacity. So the moment you say district name along with sum of capacity, then you will have to group them based on district name. You will have to group them based on district name. So from water scheme, so what will happen? From water scheme, take this relation water scheme, from water scheme. Do you have any where clause? No, sir. No where clause. Therefore, all the tuples will be selected. Then group them by district name. So one group of Ajmer will be created. Another group of Bikaner will be created. Another group of Churu will be created. And another group of Dungargarh will be created. So what will be produced by this? A district name and the sum of capacity. So please, if I tell you that what will be the output of this particular query, sir, it will have district name, and then it will have sum of capacity, right? So first will be Ajmer, and the summation of the capacity with respect to group Ajmer will be 20 only. Then you will have Bikaner, the summation will be 40. Then you will have Churu, the summation will be 30. Then you have Dungargarh, the summation will be 10. So this is the output of this first subquery. Please try to understand. This is the output of this first subquery, which will be renamed by a new name total. So a new name will be given to the output of this subquery. So a new name total will be given to the output of this subquery. The first attribute will be defined as a name. First attribute will be defined as a name. Second attribute will be defined as capacity. Rather than sum of capacity, it will simply become capacity. It will simply become capacity. Clear? Now what will happen? Now you will go and you will execute this second subquery. You will execute this second subquery. Now this second subquery actually works on the table total. So you will take the total table. You will take the total table. In this total table, there is no where condition, nothing. You just need to perform the average of capacity. So you will get the average of capacity. Let's look at this. So you will get the average of capacity as only attribute, and this average of capacity will be nothing but the average of all the capacities in the table total. So it will be 30, 40, 40, 100 divided by 20. So it will be 100 divided by 4. That will be 25. So this will be the total of capacity. Now what will happen? So this output of the subquery, will be given a new name, total average. It will be given a new name, total average, and the only attribute of that will be capacity. So rather than average capacity, you will call it capacity. Rather than average capacity, you will call it as capacity. So do you realize what happened? Sir, this first subquery will be renamed as a total relation, which will have two attributes, name and capacity. The second subquery will execute on the output of the first subquery, that is, it will execute on this new relation total. So it will eventually calculate the average capacity from the table total, and it will be assigned a new name as a total average, the average of total, and it will have the capacity. That what is the average capacity? What is the average capacity? Now you, after the execution of this two subquery, one relation will be total with two attributes, name and capacity. Another relation will be total average with the only attribute capacity. Now this main query will execute. So it will select from total comma total average, means it will perform the cross product of total and total average. So sir, this is total. So you will have total dot name, total dot capacity, then you will have total average dot capacity. So how do we define? All the attributes of first relation followed by all the attributes of second relation with all possible combination of tuples. So Ajmer 20, look at this. So the first tuple is Ajmer 20 will be combined with only one tuple of the average capacity, that is 25. Similarly, Bikaner 40 will also be combined with this 25. Then Churu 30 will also be combined with this 25. Now, Dungargarh 10 will also be combined with this value 25. So, from this table, it will select the tuples where total dot capacity is greater than or equals to total average, total underscore average dot capacity. So, here, sir, total dot capacity is not greater than or equals to, therefore, it will not get selected. Total dot capacity is greater than or equals to total average capacity, therefore, this will be selected. Total dot capacity is greater than or equals to total average capacity, therefore, it will get selected. Here, total dot capacity is not greater than or equals to total average capacity, therefore it will not get selected. So from this relation, these two tuples will be selected. Out of these two tuples, you will produce the name. So in the output, you will have two names, Bikaner and Churu. In the output, you will have two names, Bikaner and Churu. Please tell me if you understand that what will be the order of execution. Is it too difficult to obtain the result? So the number of tuples written by the following SQL query will be what? Sir, 2. There will be two tuples. One will be with respect to Bikaner, another will be with respect to Churu. Make sense? So things are not difficult. It's just that you have to understand that in what order things will execute. If you try to solve each and every gate question while concentrating on the fact that what will be the order of execution, then you will be able to solve each and every question that has been asked in the gate exam. So the most important thing is that understand that in what order query will execute. Clear? So we are done with the examples of correlated subquery that we have discussed. I have also explained the concept of as a clause. Generally, it will be used to rename an existing relation or existing attribute, but it can also be used to rename the output of a subquery. It can also be used to rename the output of a subquery. Generally, for the purpose of renaming the output of a subquery, with clause is used. Generally, with clause is used for the purpose of renaming the output of a subquery, but sometimes as can also be used for the purpose of renaming the or providing a new name to the output of subquery. So, such type of questions require more time to solve? No, it's not the case. It's just that while the simple concept is that while you are learning the concept of SQL, don't focus on time. Once you understand the concept, no question of the gate exam will require more than 2 minutes or more than 2.5 minutes. There will be no question in the gate exam related to SQL that will require more than 2 or 2.5 minutes. But while learning the concepts of SQL, a single question may take 30 or 40 minutes of time. So while learning, don't focus about time. Don't focus on time. Slowly, your speed will increase. Slowly, your speed will increase. But just to make things fast, if you miss some of the concept, then it will be very dangerous. So it's okay if you need some extra time while learning the concept. Spend that time and you will be able to save during the exam. You will be able to save that time during the exam, because you know that what things will be, what concept will be used in what order, and where exactly they can be applied and where exactly they cannot be applied. If you know it, if you have already seen all those things during your preparation, then things will be easy. Clear? Okay, so that will be all for today's session. We are done with execution of correlated subquery. We have seen as and with clause. We have seen the examples of as and with clause. In the next two sessions, I'll discuss some more questions that has been asked in the GATE exam. So those will also be the good quality questions and will include overall all the concepts of SQL. So that will be discussed in the upcoming classes. That will be all for this particular session. Thank you very much for joining. If you have any doubt, then please ask. Otherwise, I'll wind up the session. Oh, I don't think there is any doubt. So thank you very much. See you tomorrow. Bye bye.